Thank you for joining this 15-minute lightning talk where we're going to be talking about Kubestr. I'm Michael Cade. I'm a senior technologist at Kasten by Veeam, and Kubestr gives us the ability to identify our Kubernetes storage, validate our storage options are configured correctly, as well as evaluate those storage options using a benchmarking tool such as FIO. Let's get straight into the demo. So to start off with the demo, I want to just briefly give you one area really where we should really focus on as to where to get more information, and that would be kubestr.io. So as you can see here, it gives a bit of a brief description of what Kubestr is and how it can help. It gives you those three: identify, validate, and evaluate. And if there's three things I want you to walk away with today, it's those three things. Gives you a very short demo of how it works, but obviously this demo video will give you a lot more insight into some of the areas that it also works. It also gives you a breakdown of how to use Kubestr as a tool. So, and I'll get to the platforms that Kubestr is available for shortly, but then it gives you a bit of a rundown on how to run certain tasks on there. But again, we're going to touch on that during this demo. So in terms of where can we run Kubestr, so if we head on over here, you can see that we have the ability to deploy Kubestr on Windows, Linux, as well as Mac OS. So pretty much multi-platform, enabling us to, wherever our IDE is, allow us to run this to ensure that we can test and validate our Kubernetes storage. Okay, so in terms of what it looks like, so to begin with, if we take a look at the help command of the kubestr.exe, you can see here that we have a very simple command line driven tool in that we have the ability to run a CSI check, which we're going to get through, as well as an FIO. Now on its own, and that's what we're going to do here, this command is going to identify all of the available storage classes that we have available within our Kubernetes environment. So, and what this will do is this will leverage the kubectl config or the context that you're using to be able to do that. And I'm going to jump between two as part of this demo as well. So here we can see that I'm obviously using an AWS EKS cluster, but you can see that it does a validation on the version of Kubernetes. It does a role-based access control check, and it does an aggregated layer check. It gives you a warning about the CSI driver is depreciated and unavailable after a specific date, but that's really just that warning that we see within the public cloud when we know that there's a transition coming around CSI, which is one of the reasons why this tool is such a handy little tool, is that the enhance and advancement of CSI really does shine a light on, well, we need to make sure that it's configured correctly. So it gives you some information about the CSI driver that you have. So we're using the AWS EBS CSI driver. And you can see here that I have a storage class known as EBS-SC and a volume snapshot class CSI AWS VSC. You can also see that I have a clone here as well. And it then gives us some instructions as to, well, what do you want to run? So we've got the ability to validate, which is testing that CSI snapshot restore functionality, which we're going to do shortly. And we have the ability to perform that FIO, that flexible IO test against the storage that we wish to do. Now, what we've also got is that in-tree provider, which also may be something that you also want to get the benchmarking results from. And you can see here that we have a GP2 storage class available for that. But on this instance, we can't run the CSI snapshot validation because, well, it's not there. So the FIO test is available still in there. So if we drill down a little bit further and we check out the help for the CSI check, you can see that there's a few more options that come up, or a few more flags that we're allowed to start playing with, in that we can say to clean up the objects, and the default is true anyway. So what this is going to do is this is going to go and create a pod, an application. It's going to create a PVC. It's going to create a PV. It's going to create a snapshot of that PV, and then it's going to restore that back, or it's going to clone that back. So validating that the snapshot functionality of CSI is actually working as it should be. Now, if we didn't want to clean that up, maybe we were running some tests or wanting to contribute to Kubestr, maybe we want to keep those pods up and running so that we could dive into them and do some more work with them. We can also dictate where we want the pod to be running. By default, it will run in your default namespace. That might not be applicable. We might want to run it in a specific namespace. So we've got that option. Then a required flag would be the storage class as well as the volume snapshot class. So let's go ahead and pick those two that we just saw from running Kubestr. And what this is going to do is run through that process. So it's going to create the application, which is going to create the pod that we first mentioned. And if I open up another window here, just over to one side, and I run a kubectl get pods, you're going to see that this Kubestr pod is container creating, and it really doesn't take very long at all. And you can see already that that's running. If I also run a kubectl get PVC, you can see that we've got our Kubestr PVC in there as well. We're then going to take that snapshot. So again, we could do a volume snapshot, and you can see there that we're just keeping up with what we're doing here. And what this is then going to do is create that clone or restore that data back into the namespace, simulating that the CSI is configured correctly. Now, what it will do, and eventually this will complete, it doesn't take very long at all, but what this will do is validate and give you an OK or a thumbs up. Now, if your CSI is not configured correctly, maybe you don't have the snapshot controller configured quite right or within the correct namespace, is one of the areas that I've seen, especially within AWS and EBS and the CSI driver that you manually have to implement, is it's going to come back and give you some information about what is happening, why it's not working. At that point, the Kubestr pod and the PVC will still be in place as well for further troubleshooting alongside that. So you can see here that we've created the snapshot, and now we're restoring that application. And you can see there that we cleaned up the resources. So if I now just go up and check that volume snapshot, we can see that that's been removed. We should also see that the pods have also, they're being terminated, as well as then finally back on here, you can see that the CSI checker test is that the application successfully snapshotted and restored. And that's really the key to success from a validation point of view, to say everything is good from that angle. So then, like I mentioned, this is around being able to test against not just day zero, validating your storage options, identifying your storage options, but also being able to be a useful tool on your existing clusters. And you may have clusters in various different locations. So in this instance, I'm going to quickly just jump over to my Microsoft AKS, so Azure Kubernetes Service cluster, and I'm going to run the same test against my Azure Disk CSI, and hopefully that is still up and running. But again, what this is going to do is it's going to go and create that. It's going to go and create that pod. It's going to go and create that same process is going to happen here. And if I go, okay, so we're definitely on our AKS cluster. If I then run get pods, we should see our Kubestr container creating. We should see the restoring of the application happening. And there you can see the clone there in this instance. So this is the PVC that has been cloned from the snapshot, and the restore is ongoing and happening within there. And you can see there that was super quick because I'm using different nodes. I'm using different storage and compute nodes within my AKS cluster with much more memory, much more CPU, which does actually affect the storage capabilities that you have within your cluster. So we could also run that against the Azure File CSI as well, but this is really to highlight that this is around validating that your CSI driver, your snapshot and restore functionality, or the snapshot functionality from the CSI driver, is configured correctly and fit for purpose from a data management point of view. But you can hopefully see the advantages of being able to see or validate that your storage is configured correctly. So then we get on to the evaluation of the storage. So let's jump back into our AWS cluster and clear that down so we can see. So now we want to focus on running Flexible IO. Now, Flexible IO has been around for quite a number of years, open source, gives us the ability to benchmark our storage systems. So here you can see that we've got our options, our flags that we can use. Again, namespace, size, string, etc. So if we just want to run a basic FIO test using the default, which is a 4K random read or random write, as well as a random read write 128K block size, then we can just get going there. And that what this is going to do, in the same vein, is going to go and create another pod or another application. But you can see here that it's now that FIO pod. And this is going to take about a minute to run through and run that scan against the storage EBS-SC. So it's running that FIO test that I mentioned, the default FIO, on storage class EBS-SC with a PVC size of a default of 100 gig. Now you'll see in later commands that I can run that against a 400 gig or bring your own or pick your own size that you need for your workload. And that's really the key here, is that I'm demonstrating something against some storage that I really don't know what the workload looks like, but you will be looking for, well, what does my database need to look like in terms of performance with X amount of users? So you can then choose what that looks like from an FIO perspective. And what you can also do is obviously run this from a day zero point of view, so that you know that the storage that you're putting this on is performant enough, both the storage but also the compute, and then also being able to run that against day two operations and make sure that the storage that you've already purchased or the ones that you're already consuming is also configured correctly. So you can see here that just from a random write, and this is how it outputs that FIO results. So we can see that from a random read IOPS point of view with a 4K block size, that we get an IOPS value of 461. For write, it's 507. Then you get to see that block size change to 128K, and you start to see the IOPS decrease actually, but obviously gives you an idea of what that looks like. So we could go through that and it would run a similar and potentially give us more IOPS against that. We can obviously jump back into our Azure and run the same test against that. The other interesting piece here is that we can also jump into the pre-configured or community-led FIO configuration files and use those as our test bed. So if there's one that you generally use for your application, or you've created your own for your application, well, you can bring your own -f, bring your own file, and here you can see that on that it just walks the file system backwards, reading the file, so, and then gives you the output to that. Kubestr is a handy little tool that enables you to explore your Kubernetes storage options by being able to identify the storage options that you have available within your cluster, both from a day zero point of view and onwards. It validates that the storage options are configured correctly, especially around data management tasks such as snapshot and restore. And then it also allows you to get some performance benchmarking in the way of evaluating that storage using flexible I/O. Hope that was useful. Thanks for watching.